Okay, so we are going to continue with what we were working on. Okay, so it's 12.4 polynomials. We did some like defining of the different parts of a polynomial, and I'm trying to remember where we left off. I'll find it. So just to kind of recap, the term could be a single number or variable, or like 2x, that would be a term with a number multiplying a variable. Polynomials just consist of multiple terms: monomial 1 term, binomial 2 term, trinomial 3 terms. Like terms, right? They have to be exactly the same in order to combine anything. We had done those. Okay, I think this is where we were, right here. So we're going to simplify the polynomial if possible, and write it with descending powers, then give the degree of the result and tell whether it is a monomial, binomial, or trinomial, or none. Okay, none is a possible answer. So whenever you simplify polynomials, your goal is to look to see if there's any like terms. If there is any like terms, then you could actually combine them. And the only way we can combine like terms is if they are, in fact, alike, which means the coefficient does not have to be the exact same number, does not have to be the exact same sign. It's your variables and your exponents. Those have to be the exact same variable and the exact same sign. So let's look at problem 1. I have, what is that, like a fuchsia? I have a 7a to the 7th power, so 7a to the 7th. And then what I'm concerned with is just looking at the exponent mainly, right? I've got a 7. I don't even see another 7. So that means that 7a to the 7th doesn't even have anything that's alike, right? So I would just leave that alone. I'm not going to underline anything else with fuchsia. Now with orange, let's do our second term. I have a negative 7b to the 3rd. What I'm concerned with, honestly, is that third power. Does anything else have a third power? Then I can look to see and be like, okay, is it on the same variable, right? Nothing else even has the same power, the same exponent of 3. So moving on, I have a positive 2a to the 9th. Nothing else has that exact same variable, exact same exponent. So moving on, I have a positive 11b, and that's just like the exponent is 1. There's not anything else that's alike like that, right? So this means that I actually can't combine anything, and there's nothing wrong with that, y'all. If you can't combine anything, you can't combine anything, okay? What we're going to do, though, is we need to rewrite this with our powers being in descending order. What that means is we want them to have the highest exponent go down to the lowest exponent. Also keeping in mind, because later you will start to have multiple variables with a coefficient, so it'll be like 7xyz, right? You kind of keep the alphabet in order as well as making sure your powers are descending, okay? So for this one, we're good because they either have an A or they have a B. I would start with my A, like I said, keeping the alphabet in order, and then I would start with the highest exponent. That would be 2a to the 9th power, right? Use that one. It was positive. I left it positive. Then we have a positive 7a to the 7th. And then now I have my B variables. I want to write them in descending order, so that would be my negative 7b cubed. And then I have a positive 11b. This would be none. Oop, I was going to say non. Yes, it is a polynomial, but it's not just 1 term, 2 term, or 3 term. Therefore, we just identify it as none. Okay, so I should have enough time. I'm actually fixing to teach a class to do this example. Probably don't have to really scoot up. Okay, so let's see. 6a to the 7th. What else do I have that has a to the 7th? I actually do have something. 6a to the 7th. 2a to the 7th. I can do math there. I can actually combine these because they are like terms. Look at the coefficients. 6 minus 2 would be 4. Keep your variable, keep your exponent, right? I use those. Now, b to the 7th. I would choose this not only because it's the next term in line, but also because if I'm combining, knowing that I'm going to eventually have to write it in descending orders, why not already go ahead and start picking out the ones that I know would be next? Does that make sense? Hopefully. So if I'm looking at all my b's, I would be like, oh, let's look at the b to the 7th. What else is with a b to the 7th? Nothing. This is the only term that has a b to the 7th. So it's just plus 5b to the 7th. And then let's look and see. I've got just b raised to the first power. I've got a negative b, and I've got a positive 11b. There's that invisible 1 right there, y'all, right? I don't like using this thing, but, you know, it's working out-ish. There's an invisible 1 there, right? So I'm going to say that's a negative 1 plus 11. Signs are different, so what you do is subtract, keep the sign of the larger, keep your variable, keep your exponent. That would actually be the correct answer for simplifying that polynomial. And then because there are 3 terms, we would say it's a trinomial. I thought maybe, oh, right in cursive it'll be easier. Nope. That's actually a trinomial. Okay, so let me see what else is here. I'm going to go ahead and stop this video just because I need to make sure I have enough time to do both of the adding and the subtracting polynomials. I'll record today's lecture and we'll actually have different examples to do for 12.1 and 12.2. Okay, y'all? Okay, if y'all have questions, make sure you ask. Thanks. Bye.